Hi everyone, I'm Yiru. This is a presentation for Innovandi Nanocem PhD Prize. These are my supervisors, Professor Barbara Lothenbach and Professor Karen Scrivener. I will present my PhD thesis with the title Effect of Alkali Aluminum and Equilibration Time on Calcium Silicate Hydrates. In this era, infrastructure development, including houses, buildings, roads, and bridges, is rapidly expanding, with concrete being a primary construction material. However, cement production contributes 5 to 7% global CO2 emissions. Notably, the majority of these emissions come from raw materials, with 60% from limestone processing. To reduce CO2 emission, we can decrease clinker content by using SEMs or limestone. But this alters the composition and structure of CSH, because SEMs often contain significant amount of aluminum and silicon, impacting pH values in hardened cement and further the concrete durability. However, important questions regarding the effect of aluminum, alkali, and equilibration time on cache structure and solubility are still not fully understood. The objectives of my PhD thesis are to understand the alkali uptake and aluminum uptake mechanism in CSH and to understand the effect of equilibration time on cache formation. Besides, I want to build an experimental database with various calcium to silicon ratio, aluminum to silicon ratio, alkali concentrations, and different equilibration time. So here is my research. I add calcium aluminate, calcium oxide, and silica film in alkali hydroxide solution or molecule water. I have different calcium to silicon and aluminum to silicon ratios. Then the samples are shaken under nitrogen for different equilibration time. When the samples are ready, they are filtrated under nitrogen. The solids are then measured by TGA, XRD, and spectroscopy methods, and the aqueous phases are measured by IC and pH. I was also using thermodynamic modeling, and the newly developed CachePlus model was used in this research. Here I show you the effect of aluminum in CSH. When I add more aluminum in the system, dissolved aluminum concentration increases. Also silicon concentration increases. This is because aluminum uptake in high air cation chain and substitutes the silicon in CSH. In contrast, calcium concentration decreases. Why does that happen? This is due to the growth of calcium oxide sheet along the silica chain. So with more aluminum in the system, the silicate main chain length would increase. And this is confirmed by the FTIR results as we see the decrease of Q1 signals. Next, I will show you the effect of alkali hydroxide on aluminum uptake. See when pH value increases, dissolved aluminum concentration in solution increases, and also the aluminum to silicon ratio in CSH increases. Similar slope was observed for different pH values, so we assume that the aluminum sorption site in CSH is pH independent. Regarding the impact of equilibration time on CSH, initially after 6 hours, there is a notable presence of pollandite with some CSH. After 1 day of equilibration, pollandite content significantly decreases, and CSH reflections become more prominent. With longer equilibration times, the intensity of basal peak and the hump of the 101 increase, indicating more Q2 at bridging sites within the CSH structure. The KD values of aluminum reveal that with longer equilibration time, the absorption of aluminum in CSH rises steadily, even after 3 years, especially in CSH with high calcium to silicon ratios. Conversely, the absorption of sodium in CSH diminishes over time. These findings indicate the long-term rearrangement of CSH structure. Additionally, the cash plus model shows very good agreement with the long-term aqueous results. This is my thesis. Thank you.